All right, so this is going to be one of your reviews for your test. Now, it looks like your test is on everything that we've covered so far this school year. All of Chapter P, we wanted to include everything under one single exam before we start Chapter 1. All right, so this is going to be a good mix of everything that we went over so far this school year, starting with some exponents. All right. So with the exponents, if we remember, we need to remember the rules of exponents. They're gonna creep up on you throughout the school year, and they're gonna appear in places where you maybe won't expect it, right? So it's good to know them at all times. All right. But what I like to do is I like to move all the negative exponents first. Doing that first is gonna get you that -4 from the bottom to the top, right? It just switches its position. So it's going to be a 2x to the third, y squared, y to the fourth, over 5, all to the -3. All right, and then I can simplify 2 plus 4. Because the bases are the same, we can add the exponents. So this is going to be 2x to the third, y to the sixth, over 5 to the power of -3. And then now that that's done, you can either distribute that -3 or you can change it to a positive by flipping the top and the bottom, which is what I like to do. I like to handle all of the negative exponents first, all right, and then make everything positive. So I'm going to flip. It's going to be a 5 over 2x squared y to the sixth to the +3. And then from here, I can distribute that exponent to everything. All right, and then 5 to the third over 2 to the third times x squared to the third times y to the sixth to the third. I would hope that at this point you guys don't have to write this step down. I'm just writing it so that it's extra clear. All right, 5 to the third power is 5 times 5 times 5, so 125. 2 to the third is 2 times 2 times 2, so 8. Power to a power you multiply, this is going to get you x to the sixth. Another power to a power you multiply. So it's going to get you y to the 18th. And that's your final answer here. All right, so not too bad. All right. And then there's 2 here that say simplify. All right, I know we learned a lot of stuff so far, but I saw in class a lot of people tried to overcomplicate these. If it just says simplify, you're writing it as a simple singular polynomial expression. All right, so anything that you see in front of a polynomial in parentheses, you distribute. So I'm going to distribute that 4 everywhere, and I'm going to make it a 4x plus 12x squared minus 4. I can take that -5 and also distribute it. It's going to be a -5x squared minus 15 plus 35x. And then once you have this, you just combine like terms. All right. Nothing new here. All right. It's algebra that we're hopefully by this point pretty familiar with. All right. So then we combine like terms. We get 7x squared plus 39m. -4 minus 15 is going to get you a -19. And then we get that as our final answer. All right, so something similar with the next one. I can just FOIL it, right? Same exact rules for our polynomials. Again, I know you guys learned a lot of things. Try not to get overwhelmed with the material, right? And don't forget something basic like FOILing, right? So we're just going to do first times the first. Let me use a different color, actually. First times the first. So -4m times 5m is going to get you -20m squared. Outer times the outer, -4m times 1 is -4m. 3 times 5m is going to get you 15m. And last times last is 3 times 1, so 3. And then you just combine like terms. So I get -20m squared plus 11m plus 3. Again, like I said, try not to confuse yourself with just FOILing, right? This shouldn't be super difficult of a problem. All right. Same thing with factoring. We've done a lot of factoring at this point, and it looks like a lot of you did really well with the factoring, right? So just keep up that momentum for this upcoming test. and you should be fine, right? The first thing that we always look for when factoring is a GCF. It looks like here I can take out a 4x, and when I take out a 4x, I'm left with an x to the third minus 125. All right, you can do long division if you need to. I know some of you in class were able to just do this right away. That's fine. All right, but then once you do this, you don't want to stop right here. You want to look on the inside of your parentheses and see if there's anything else you can factor. And it looks like x to the third minus 125. Hopefully we can recognize at this point that that's a difference of cubes. All right, so I get a 4x on the outside, and then I'm going to set up my same, opposite, always plus. All right, same is going to be a minus, opposite is going to be a plus, and always plus is plus. All right, so then it's going to be the cube root of the first, so x, cube root of the second, so 5. And then in my parentheses is going to be the square of the first, square of the last, and the product of the two in the middle. Nothing more we can do to that. That is our final answer. All right. Now, if you look at this next one's a little bit different, right? So I didn't quite show you guys an example that looks like this, but I saw in class, a lot of you actually got this one, which I was really impressed by. A lot of you got this one, but I mean, it should look like the same pattern as just a regular trinomial that we've done before, right? So off to the side, I'm going to write y squared minus 13y plus 36. Hopefully you guys can see something like this and be able to factor it, right? You're just looking for factors of the last that add to the middle. So y minus 9 and y minus 4, right? Same exact thing here. Even though maybe it's not super obvious, hopefully I saw a lot of you could make the connection that these are very similar, right? It's going to factor exactly the same way, x minus 9, x minus 4, but because this one is raised to the fourth power, this one is squared, x to the fourth power is the same as x squared squared. So it does follow the same pattern as you have something squared minus that something plus a constant, right? So it's just going to be x squared minus 9x squared minus 4. All right, hopefully that makes sense. These are now difference of squares, right? X squared minus 9 becomes x plus 3, x minus 3, and then x squared minus 4 is going to get you an x plus 2, x minus 2, right? If this part is still confusing to you, FOIL it and verify that you get this as your answer, right? So hopefully it makes sense, right? It shouldn't be anything too crazy. A lot of you, even after I explained it, were able to get it, right? We'll do these more in depth in the middle of chapter 1, right? Factoring these kinds of problems. But this is like a nice little introduction to that, right? Hopefully not too bad though. All right. So now moving on to something like this. This is where we got to our rational expressions. So moving past our factoring, right? Don't forget the factoring, right? Make sure to review all that as well. But right, the rest of this review is, I think if I remember correctly, dedicated to newer stuff. All right. So this is a multiplying problem. A multiplying problem, all I want to do is factor and then cancel anything that matches on the top and on the bottom. All right, so looking at x squared minus 16, that's going to be an x plus 4 and an x minus 4. Looking at the bottom, x squared plus 8x plus 16, that's a perfect square trinomial. So you can write it as x plus 4 squared, or you can write it twice. Either way is fine. I feel like if you wrote it twice, it's a little bit more obvious what cancels. So that's what I'm going to do. I'm just going to write it twice. You can write it squared if you want to. But again, that's just how I do it. The x squared plus 4x, I can take out a GCF of x, and I'm left with x plus 4. And then it looks like on the bottom, I can take out a GCF of 3. And I'm left with x minus 4. All right, so this is exactly what we did in the multiplying and dividing rationals lesson, right? So we just factored and canceled anything that matched. It looks like I have an x plus 4 that matches. I can cross cancel when you're multiplying, not when you're adding and subtracting, but when you're multiplying, you can cross cancel. I have an x plus 4 that matches another one, and then I have an x minus 4 that matches. All right, so the only things that don't match are the x and the 3. So I'm left with an x on top and a 3 on the bottom. All right, and that's all we have to do for this one. All right, so fairly easy one, but I mean, I saw in class some people were a little lost on how to do it, right? Again, it's a lot of material. I don't want you guys to get overwhelmed with the amount of material. Just be sure that you understand each lesson before you try to tackle a whole review of the comprehensive stuff, right? So it is a lot of stuff, but make sure you're comfortable with everything. All right. Now the adding and subtracting one required a little bit more work, and this one especially, this one's a little bit longer than some of the other ones just because there's a lot to factor before you can add and subtract. So just like before, I'm going to try to factor everything, right? It looks like the top, I can factor out an x squared, and then I get an x minus 1. It looks like the bottom is already written as factors. Might not be super obvious, but again, that power of 3 is the same as x minus 1 times x minus 1 times x minus 1, right? It's not a difference of cubes or anything, right? Again, don't get freaked out over the amount of material, right? It's literally just x minus 1 times itself 3 times, nothing more than that. All right, and then the x squared plus x, I can take out a factor of x. And then the x squared minus 1, I can separate that as a difference of squares. All right. And now with adding and subtracting, you cannot cross cancel. But if you look at what we just got when we factored, things do cancel within the fractions, right? This x minus 1 and this x minus 1 can cancel. And I'm left with x squared over x minus 1 and x minus 1. Again, you can write x minus 1 squared if you want to. I'm perfectly fine with that. There's nothing wrong about that. All right. I'm just going to leave it like this just so that we can see what we have to do in the next step. All right. And then in the next fraction, the x plus 1 and the x plus 1 cancel, and you're left with an x and an x minus 1. All right. So I just simplified the fractions before I decided to continue adding them. And now that we have this, we see that this is a lot simpler to add. All right, so we can see now that we're looking for a common denominator, right? Adding two fractions, I want to make sure that they have a common denominator. And to do that, let's look at the factors, right? This one has an x minus 1 and an x minus 1. I can write that once to account for both of them, but then I also have an extra x minus 1 that I need as the factor, right? So x minus 1 and x minus 1 is my least common denominator. So I'm going to look at that over here. X minus 1 and x minus 1 already exist under this fraction. So the only thing that I'm going to bring over is that x squared. I don't have to do anything to it. All right, but this one, it has one of the x minus 1s, but not the other. So what I'm going to do is I'm going to multiply the top and the bottom by x minus 1. All right, and then doing that, it is a plus, so I can just distribute a positive x to both of these, and this is going to get me a plus x squared minus x. All right, and then the very last thing I can do to fully simplify is I would combine the x squared and the x squared, and I would get a 2x squared minus x over x minus 1, x minus 1. All right, so this is a perfectly acceptable answer. Another perfectly acceptable answer, I know some people factored it. You can factor the top. That's also a perfectly acceptable answer. And some people wrote x minus 1 squared. Just to condense it a little bit more. All right, these are both perfectly acceptable. One is not better than the other. They're just written differently. All right, so that's perfectly fine for that one. All right, so now let's try one with a minus. All right, so with the minus, it's the same idea. I like to factor everything. All right, so x minus 2 over x plus 2, this is already fully factored. X squared minus 4 is going to be an x plus 2 and an x minus 2. All right, doesn't really help us in terms of canceling, but it does help us in terms of finding out what the common denominator is. Now, if you notice, they share an x plus 2, so I only need to write that once. But there's also an x minus 2 that we need to account for. All right, so I don't want to repeat the x plus 2. I just want to write it once. And then I'm going to write the x minus 2 just to account for that as well. All right, so it looks like over here, what's missing is the x minus 2 in this first fraction. I can multiply the top and the bottom by x minus 2. And then doing that, I can FOIL the top, right? That's going to get us x squared, right? And then that's going to get us a negative 2x. Another negative 2x is going to get us a negative 4x. And then negative 2 times negative 2 is a positive 4. All right? And then that's that first fraction. Now, if you look at this next one, it already has the denominator that we're looking for. So I don't need to do anything to it. I can just bring over that minus 3 and then just fill it in on the top. All right? So what we're left with on the top is an x squared minus 4x, and then combining like terms, 4 minus 3 is just plus 1. And then on the bottom, I get an x plus 2 and an x minus 2. Nothing more I can do to that. You can check if we can factor, but we can't in this case. We would just leave it alone like this. All right, one more last one in this particular review. And again, as always, if you want more practice, there's another review published in Canvas, right? It looks like a little worksheet. So it doesn't look exactly like this. It's just another worksheet with a compilation of just a bunch of problems across all the topics, if you need a review. You can also look back at old notes, old homeworks. I mean, everything is perfectly valid to study, right? Anything that was that you would find helpful, all right, is available to you. All right, but the last one in this particular review is a complex fraction. Now, again, with a complex fraction, you want it to look like a fraction on top of another fraction. And if you don't have that right away, you need to get it as a fraction over a fraction. Right now, it looks like there's too many fractions here. I just want one single fraction on top and one single fraction on the bottom. So I'm going to do the exact same thing as I did with the adding and subtracting lesson. And I'm going to look at my denominators and see if they have any common factors, right? So 2 and m plus 5 do not share any common factors. So I'm going to have both of them under a single denominator, all right? And then doing that, I'm going to go one by one, and I'm going to look over here. It looks like over here, it needs the m plus 5 in order for it to match. So I'm going to have an m plus 5, all right? So it's going to be a 3m squared plus 15m, right? We can distribute that 3m. All right, and I can do the same thing over here, m plus 5. It has the m plus 5, but it's missing the 2. So I'm going to multiply the top and the bottom by 2. And don't forget, this is a minus, so it's going to be a minus 2 times 36, which is 72. All right, and I'm going to do the exact same thing on the bottom. All right, it looks like we have the exact same denominators here, so I'm just going to write it over 2 times m plus 5. All right, and then so for this one, all I have to do is multiply the top and the bottom by 2, and so you end up with 8. And then the next one, I can multiply the top and the bottom by m plus 5. Don't forget there is a minus in front, so I'm going to distribute a negative m to everything, and that's going to get you a negative m squared minus 5m. All right, and then now we can keep, change, flip. So keep, change, flip. I'm going to keep the first, change that division and multiplication, and then flip the last fraction. So it's going to be a 3m squared plus 15m minus 72 over 2 times m plus 5 times 2 times m plus 5 over, I would write the bottom, I would write this in standard form just to see if we can factor it. All right, and then it looks like what cancels is the 2, m plus 5, m plus 5. And so what we're left with is 3m squared plus 15 minus 72 over negative m squared minus 5m plus 8. All right. I believe this is fine the way it is. You can try to factor it, right? So you can take out a factor of 3 on top, right? That'll be your GCF. I forgot the m here, sorry, 15m. All right, and then you get m squared plus 5m minus 24. And then on the bottom, looks like I can take out a -1, and I'm left with an m squared plus 5m minus 8. All right, so this is just our normal factoring methods. And then I don't think we can do anything to the top, right? The top, I'm looking for factors of -24 that add to -5. Should be a +8 and a -3, so I get a 3m minus 3m plus 8. All right, and then on the bottom, I'm looking for factors of -8 that add to +5. All right, well, there's not really a lot of factors of -8, right? -4, 2, 4, -2, 1 and 8, all right, positive and negative. So nothing really factors there. So there's really nothing that we can do. So this is just going to stay the same. It's going to be -m squared plus 5m minus 8. If you could recognize that before we did that step, you could have left it like this. That's perfectly fine. Actually, any one of these are fine. All right. I like to have it fully factored, so I would prefer this as the final answer. All right, but this is also fine. Or like this. I feel like this one's a little bit strange because you partially factored it, but not all the way. Right? Either leave it fully simplified like this or leave it fully factored like that. Is what I would say, just to keep it consistent every time. All right? But that's it for this particular review. You do have another review up if that's something that you would like to go over, just so that you have more practice. All right, so lots of material covered so far. I know we moved pretty fast and we're doing kind of a lot, but this is all useful stuff that'll prepare you for the bulk of the course, right? So if you can handle the speed, you're doing great in terms of preparing yourself for the heavy material that we'll go over in a little bit.